What, you're not checking it?
5, 6, and 7. All right, we're going to go through how you prove that those are parallelogram, given the fact that they are coordinates. All right, and again, it's so very simple. I promise, it's so very easy. So what I want to do now is I just want to scroll back to the beginning. All right, and then I want to take a look at those of you guys who had some questions. All right, so let's talk about the very beginning, please. And we have, for those of you guys who are not here, I think it's easy to justify each of these right here. In order to be successful, you have to know that's true. All right, I think one of the most important ones is this: the diagonals bisect each other. All right, and the diagonals bisect each other. That just means that when you draw the diagonal, right, when it's bisected, it creates the what? The midpoint. Do you understand what I'm saying? Mm-hmm. Right? And if you take the midpoint of the diagonals, the midpoint of each diagonal will be exactly what? It will be exactly the same. All right? And to me, honestly, that is the easiest way to prove whether or not your quadrilateral is a parallelogram. But obviously there's lots of different ways, which is what they're trying to say, or trying to show you, or trying to demonstrate. All right? So on this page right here, I think that was, we're okay with that, correct? All right, no questions here? Go ahead.
6, those were all.
Yes, right. And again, it took me a second to figure that out.
But because those two are equal.
Yes. Now, listen, because those are equal, then how do we know they're 90 though?
They're 180.
Because very good. They're supplementary. All right. So if they're supplementary and congruent, they have to be what? They have to be 90. All right. That's how we know that. All right. Yes.
They can only be 90 if it's a parallelogram. Like if it's just a normal quadrilateral.
Actually, you could have what's referred to as a.
Because you can't change that.
You see what I'm saying, right? And again, as we progress through here, I've always tried to tell kids that there's literally going to be, I'm not sure, I don't remember, I counted once like 30 or 40 or 50 rules, I don't remember. But in my opinion, it's just not possible to know all of those rules, right? That's why I try to show you visualizing things to me is so much easier. And it makes so much more sense if you don't see something, draw out the shape and look to see if it's true or not. All right, because someone asked me a question about the diagonals of a parallelogram, do they bisect the angles? It looks at first like they do. But if you make it where it's not visually exact, you can see that they don't. And besides, the diagonal cuts the parallelogram into two congruent triangles, correct? But the two congruent triangles are what? Flipped. Is everybody hearing me what I'm saying? So let me just show you real quick just to make sure. Like this problem right here, look at number 2. If I draw that in there, listen to what I'm saying. This triangle, the top triangle is congruent to the what? Bottom triangle. But now look and see if you understand what I'm saying. This does not equal this, though. Does everybody agree with that?
Yeah. No, I don't.
Right? Okay, so now let me show you why. It's good observation now. It'll help you on all the problems now if you understand this. That's why most people get in trouble because they don't understand that little concept. That looks like it's bisected. Do you agree? Right? But I could draw a different one so I could show you it's not. But what's more important that you understand is that because this is a parallelogram, now watch how obvious it is now. If that's parallel, the alternate interior angles are congruent, right?
Right.
So this is congruent to that.
Right.
You with me?
Oh, okay.
You see it now, right?
Okay.
And then what? This angle is congruent to this angle. There you go. And right, so you can see now what I'm saying about the triangles are congruent, but they're flipped.
Yeah.
Does that make sense?
Okay,
So this angle up here corresponds to this angle down here, right? And the other way around. This angle here is congruent to that angle right there. The red and the green angles are not equal.
But they don't have, like, if you erase those two parallel sides, would it mean the same thing, or since those two parallels are there?
Well, but it tells you in the direction that it's a parallelogram.
Okay.
It tells you in the direction it's a parallelogram. All right, so go.
Is there a rule that says like they're not equal?
But what's not equal?
The
The red and the
Sides
green.
each side.
The red and the green. No, let him talk now. He's get involved.
Shh.
Are the red and the green angles equal?
No, I know how they're not equal, but is there a rule that says that? Or is that just
Well, that's just something you should know. All right, that's something you should know. We could make them so they're equal.
Yeah.
Right? If I drew a square. If you draw a square, now the angles are equal. All right, and it is a parallelogram. A square is a parallelogram. You're right.
Hold on,
So there are special parallelograms, squares and rectangles, rhombi. All right, there's special ones. All right. So what we do is we say that in some cases the diagonal is bisected, the angle, but the majority of time it does not. Now it's even hard for me to visualize a rectangle. Does the diagonal bisect the angle of a rectangle? Now, what I'm trying to show you is this. So, if you draw it, look, and you'll see how obvious, right? All of the angles are 90. So when you draw this diagonal in, I think it's kind of clear to see that they do what? Not. They do not.
The angles are different.
The angles look different. And that's what I'm trying to tell you. If you draw it out and you draw it skinny enough, you can clearly see that the angles are not equal. Right? But as you shrink it to where it becomes more like a what? A square, then it's harder to actually see that they do not bisect each other. But if you draw the diagonal of a square, the diagonal of the square bisects the angle. Only for a square. Well, no, not exactly, but whatever. We'll get to all those rules. That's what I'm saying. There's so many rules that you have to remember. That's why it's good to understand. If you forget, you can quickly see that we can prove the triangles are congruent, but we cannot prove this is congruent to that. What?
So, I don't understand, but how do you tell by looking at a shape, how do you tell the difference between whether it's like a quadrilateral or a parallel? Yeah, that's what I'm getting at.
Quadrilateral just means it's four sides.
Yeah.
Shh, just stop talking and let me explain something.
So, wait,
Well,
so on 6.
You're asking me a question. I haven't even finished my explanation. All right? Quadrilateral just means it has four sides. A parallelogram is a special quadrilateral. All right? What distinguishes a parallelogram from a quadrilateral? It's the fact that the opposite sides are always what? Parallel. And when you draw a quadrilateral in which the opposite sides are parallel, it creates a bunch of things that you should know. All right? If it's a parallelogram, the opposite sides are parallel. The opposite sides are congruent. Opposite angles are congruent. The diagonals bisect each other. You see that? So now it's telling you that these are parallelograms. Because they're parallelograms, opposite sides are equal. So you would say 2x minus 2 equals 12. All right? And anything else that goes there? What?
On number 5, and then I have 2 questions on the
Come on, just...
5 would be x plus y equals 24.
Yes, x plus y equals 24. But it's easier just to go ahead and solve for x first, right?
Yeah, x is 15.
Right,
y
so
is minus
x is 15.
So y plus 15 equals 24.
Exactly. That's it.
Do you have a parallelogram that's not a quadrilateral? Is that possible?
No, because every quadrilateral or every parallelogram has four sides. So the definition of quadrilateral just means It has 4 sides.
Yeah, I was wondering if there's a way to have like a
Quad's 4.
5-sided.
Quad means 4.
Yeah.
All right. So now we're all good with the first page. Now we're looking at the second page. Now on the second page, I just kind of discuss like proofs with coordinates. All right. So there are simply lots of ways to prove whether the coordinates form a parallelogram. All right. If you're looking at, for example, number 1. All right. So they want you to prove that those 4 coordinate points make a parallelogram. All right. They say using the slope formula. So if we're going to use the slope formula, that just means we want the opposite sides to have what? The same slope. Right? That's all. So that's how you prove whether or not it's a parallelogram using the slopes. So keep in mind, if we were to draw a parallelogram, and here's what I want to show you, because I don't feel like drawing it all out, but we would just say A, B, C, D, correct? All right. Now, the only problem with doing what I'm saying is sometimes if I remember on this worksheet, they don't put A, B, C, D in the right order. Everybody see that?
Yeah, I do.
Yes. So again, I can't just automatically assume what I did, all right, thinking back. A, B, C, D. I thought it said prove quadrilateral A, B, C, D. Is everybody with me on that? So we have to actually kind of plot the points. So basically, if we're going to do this, it would be better to just say A is 0, 0, and then 1, 3 would be up here, and then 5, 3 would be up here. So guess what? This really is in the right order. All right, it is in the right order. Does everybody see that kind of mentally? All right. So now what are we checking? We're checking the slope of AB and the slope of CD. All right, so let's check the slope of AB. All right, so the slope of AB. At this stage of the game, I'm just expecting you to just tell me what the slope is. All right, so it would be 3 minus 0 over 1 minus 0. So the slope is 3. Agreed? Slope formula, y2 minus y1 over x2 minus x1. All right, now I need the slope of CD. So the slope of CD, 3 minus 0 over 5 minus 4, 3 over 1 equals 3. So far, we're in good shape. All right, so now that we've checked A, B, and C, D, we're going to go ahead and check what? BC. So the slope of BC and the slope of AD. So BC is 0. Is everybody okay with that? And the slope of AD, 0 minus 0. So it has to be 0. So we've now just proven that that quadrilateral is a what? Parallelogram, because the opposite sides are what? Parallel, because the slopes are equal. Yes, ma'am.
Why is the slope of BC 1?
Well, tell me what you think. Why is it 1 to you?
Because the difference between 3 and 1 is 2. The difference between 5 and 3 is 2. 2 over 2.
BC. Is that what you're asking me?
Yeah.
How are you getting 1 from that?
2 divided by 2 is 1.
How are you getting 2? Come on.
Because the difference.
Shh! Stop. I'm trying to teach you something.
The difference in x-axis and y-axis.
Are you asking me about BC?
Yes.
So how do you find the slope?
You do the slope formula.
Which is?
y2 minus y1 over x2 minus x1.
So how are you getting what you're getting?
Y2
Is?
minus x, y1. Oh, I've twisted up.
All right. So we're good now. All right. So now let's take a look at the distance formula. All right. So again, if I wanted to prove that the quadrilateral is a parallelogram, the opposite sides have to be what? The opposite sides have to be equal. All right. So again, we should practice the distance formula. So just to review, distance is square root x2 minus x1 squared plus y2 minus y1 squared. So everybody with me on this? All right? x2 minus x1 squared plus y2 minus y1 squared. Now, the dumb thing is we have to do that what? 4 times. We have to do that 4 times. But it's the Pythagorean theorem, yes. But listen now, what I'm trying to tell you is the numbers are so small that you should be able to easily do it in your head. All right? So let's practice. So I want RS. So RS is equal to the square root of, well, that one's kind of obvious, right?
2.
Y2.
Because 3 minus 1.
3 plus 1.
Yeah, I knew that. It's 4, so it's obviously 2.
Yes. 4 squared.
That's what I said.
4 squared plus, and we'll just do 0 squared because I don't want to confuse anybody. All right? So 4 squared plus 0 squared is what?
16 plus 0.
Brilliant. Thank you. Remember, we're practicing mental math here, guys. And some of you obviously need a lot of work in here.
Wait, what's the square root of 4?
It's not the square root of 4. It's
Oh, they
4
cancel out each other.
squared
Yeah, they
and then
cancel out
square
each
root. Or you can remember, squares and square roots cancel out. That's what I'm saying. It's a good review
Wait,
today.
but then, okay, honestly, if they cancel out each other, why are they even there? Why is it not just x2 minus x1 plus y1 plus y2 minus
Very good question, because you can't take the square root through addition. The only reason this works is because you're adding 0.
Okay.
All right? So now we have RS. Let's do ST. See if that's any better. So ST. All right? 3 minus 2.
1.
1 squared.
1.
1. Now, 0 minus or 0 plus 3 is squared. 9. So ST is radical 10. I'm doing ST, right? Are you having trouble with 3 minus 2?
No.
Okay, so are you having trouble with 1 squared?
Sorry, I don't know what I was thinking.
All right. Now, we have ST as the square root of 10. Now I'm going to go ahead and do what? TU. All right, so let's see what we got for TU. 2 plus 3, 5 squared, 25, and then, plus 1, right? Which is the square root of 26. So right now I would say that,
They're not.
yes, but guess what? I think now I'm recalling from last year, they just randomly put the letters in. All right, so one of those could actually be the what? The diagonal.
What?
Right, does everybody see that? One of those could be the diagonal.
What's that?
So
I don't know.
you have 4 points, right? If you draw from the opposite corners and you find that length, that is the diagonal, not the side. So if this doesn't come out to be equal, then probably one of them is the diagonal. All right, so we have to look at the number or look at the coordinates better. So what we're going to do is we're going to graph this out. So negative 1, 0 would be right here. This is R. So now 3, 0 would be over here. This would be S. And then 2, negative 3 would be here. That would be T. And then negative 3, negative 2 would be over here. So that would be what? U. Do you understand now what I'm trying to show you? Right? So this is the actual parallelogram. So the parallelogram is really RSTU. So RS is okay, right? ST was okay. Wow. So then TU. No, so it's not then. You're right. Yeah. It did work out. So it's just a quadrilateral. All right, it's just a quadrilateral.
And how would you know if it's a diagonal?
If I accidentally did SU, that would have been the diagonal. Right? That's what I'm talking about. Yes.
I don't understand what you said.
About what though?
About matching the
Okay, so see what happens is, and Reagan finally understood what I'm saying. So listen, if I put the letters in the wrong spots, I could be finding the length of the diagonal instead of the length of the side. That's why it's important to plot the points. The reason why I'm going to plot the points is so I don't accidentally do the what? I don't accidentally do the diagonal. Yes. Hold on. Go ahead. Come on. I'm glad you're asking.
Okay, so what is the importance of 4
Okay, so those were the lengths of the sides of the quadrilateral. And we're trying to say, is it a parallelogram? And in this case, I can stop because the opposite sides are not equal.
Oh, so that's why you didn't go.
All of them, opposite sides have to be equal. So all 3 of them are different. Now, I was hoping TU would be either 4 or square root of 10.
Why didn't you just, sorry, if you plotted it first, could you only do 2 of them? Or did you have to do 3?
Well, that's what number 5 is going to get into.
And my second question is...
That's all right. Go, quick.
All right, if TU was either 4 or square root of 10,
Then we'd have to go on.
would you have to?
Yeah, because
You have to figure out the last one.
you have to figure out the last one.
To make sure that it's...
The one to figure out 3 aren't. One isn't the same.
Yeah.
Exactly. If all 3 are different, there's no way it can be.
But if the third one is either 4 or square root, then you have to find a lot.
Yes. There you go. Quick.
Is that why you didn't do RU? Because you didn't know those were equal, so you didn't even have to do RU?
There you go. Perfect.
If it gave you the parallelogram like RSTU, parallelogram, you would have to plot it.
Right. That's what I thought it said.
So if it's diagonal,
You see what I'm saying?
5. If that's how
It says here, graph each quadrilateral. You hear me? Look. It says graph each quadrilateral. Determine whether it's a parallelogram. It doesn't say prove the parallelogram is right. All right, so that's what we're doing. So we're just showing you the different ways. All right. So now, question number 5. Yes, go.
I jumped back on 3. Shouldn't U be higher than T? Because U is only -2 and T is -3.
But I didn't graph it. I just put the points in the general location.
Oh.
You with me? I'm trying to avoid the graph. All right.
Okay.
Now, again, personally, I think let's do this now. All right. Let's go ahead and do 5 the way they want you to do it. Now, again, on your test last year, I think what I ended up doing was telling them exactly how I wanted them to look at it. But the easy one is the midpoint. And I'll show you what I mean there. Just do the midpoint, and if the midpoints are equal, if the midpoint comes out to be the same, then it's automatically a parallelogram, which we'll discuss on number 6 in a second. All right, but I'm going to copy that. And now what I want to do is, I'll just graph this down here just so I can show you what we're talking about. All right. You click on the last page,
You can move the graph.
right? Here we go. All right. So now what I want to do is just to try to show you what they're saying. All right. So now if I graph this right here, -2, 4, -1, -1, 3, 1, 2, 3, -4, and 2, 1. Right there. All right, so personally, sometimes I used to feel like if you graph it, it's just much easier to do, honestly. All right. So again, in this case, they want the distance and the slope formula. All right. So now, if one of the rules is if one side is parallel and it's congruent, it must be a parallelogram. Hear what I'm saying? If one side, opposite sides, are both parallel and congruent, then it's automatically a parallelogram. So what we're going to do here is we are going to show that this is both parallel. We're going to show that it's both parallel and congruent. All right. Now we need some work on here, so I really want your attention, guys, because you have to be good at distance formula. You have to be good at mental math. You know, you're going away next year, and you just should be able to look at things and say what the answer is. All right. So right now, I want to know if it's parallel. So what we're doing is, and again, look how this all ties together. The slope. All right. What we're going to do now is we're going to find the slope. So from here to here represents the slope. So that slope is 3, and this is 1, 2, 3, 4. Yes, negative 3/4. Thank you. You can barely even read that. So here we go. Just a second.
Why did you not use the
What formula?
What do you use in the first problem?
Because I'm showing you honestly that it's easier if we just go ahead and do what? If we just count it. That's what I'm trying to show you. So she has a good question. A little frustrating, but that's okay. She asked me a question. Why I didn't just use the formula. You can honestly use the formula. All right, I'm not arguing with you. But I said, if we're plotting it, in my personal opinion, it's easier just to look at the slope. You see what I'm saying? The rise over run. To me, that was easy. Now, the next thing I want to show you is, down here, it had to be the same thing, right? So from here and from here, that's what? Negative 3 and 4. Please pay attention and listen to that. Does everybody agree? That's the same. You agree with what I'm saying? Showing you. So we know now that the slope is negative 3/4. And it has to be the same for now, because if the slope is exactly 3/4, the hypotenuse, which you already know because we've done Pythagorean triples, 3, 4, not yet, we're getting there. 3, 4, 5.
You
Right.
talked about it much.
Yes. So that's 5. Now, how did I know that was automatically equal without even doing the problem? Because we're doing a squared plus b squared equals c squared. Right? It's a right triangle, and I'm trying to find the hypotenuse. Right? So if the slope is the same, listen now, here's the hard question. If the slope is the same, does it automatically guarantee that it's a parallelogram? No, because the lengths could be different. That's right. It could, in fact, be a trapezoid. If I extended that line, all right, and now I measured from here to here, it is no longer a parallelogram.
It's a kite, right?
All right? Yes, go. Okay, so if you think back to 7th grade or 6th grade when you first taught a squared plus b squared equals c squared, it's a special case. And I think that's coming up in the next chapter, actually. All right? When we get into the trigonometry, it'll be fun.
If you have to use a parallelogram by the slope form or the distance one,
Hey, hold up.
could you draw 2 diagonals and then find out if like the distance of the
Okay, yes, I think so. But that's what I was trying to show you. They specifically want you to do it this way.
okay,
All right?
could you prove
Yes,
that?
we're doing alternatives here. So we have now just done, hey, we've just done the distance and the slope formula. So hopefully that makes sense.
Wait,
If opposite sides are parallel and they're the same distance, then it's automatically a parallelogram.
okay.
Let me go back
That's a
down.
little graph.
Yeah.
I didn't see the slope formula.
I didn't. But I did it with my hand.
With your hands.
Down 3 to the right 4. That is
No,
the
no, no.
slope.
Wait, but
Then what about distance?
Okay, so now that's what I've been discussing. So listen to me. Hey, everybody's not sure now. Listen to what I'm trying to tell you. All right? Try to listen to what I'm saying now. This right here has to be the same as this length right here, because this forms a right triangle. This forms a right triangle. So if I form a right triangle with side 3 and side 4, the hypotenuse has to be the same.
And then this is just a question. Why did you not do the other side?
That's a very good question. That's what I was trying to tell you back up here. So let me go back up here. Shh. Back up here. You can prove a quadrilateral is a parallelogram using any of these methods. So if two sides are equidistant and they are parallel, then it's automatically a parallelogram. Those are the rules.
Equidistant meaning then
Same distance from, yes. All right. Hold on, Mr. Butler, what?
So, can you go back to the
Drawing, yes, I can. Here we go. I'm listening.
How do you know the right triangles? Or is those right triangles?
How do I know they're equal? Okay. So this is what I'm trying to tell you. Look right here. Please look up. It should make sense. If I do this, all right? If I draw this down to, and I say over 3, and I come down here and say, I'm going to do the same thing. I'm going to go down 2, and I'm going to go over 3. Would you agree those are exactly the same? Right? Okay. So if those are the same, then that hypotenuse or diagonal must be the same. Side angle side. Beautiful.
It is.
Yes, it does.
How do we okay, go back to that?
Yes, here we go.
How do you I still don't understand how you got
Okay, so I want you to do now a squared plus b squared equals c squared. That's the relationship. A, b, the hypotenuse is c.
Oh.
3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is...
5. Where'd you get the square root?
Yeah.
17.
Pull that out of nowhere, didn't you? Is that a cube? Oh, you have to get rid of the square. Yeah.
Oh, okay. Now it makes sense.
Good.
Okay, so like I see how you got that, but I don't like.
Hold on a second. William, you guys, you're interrupting.
I'm not gonna want that.
Go.
Okay. What if those were different slopes? Like I know how you got 25, but if those were
you
different
have-
slopes, you wouldn't have been able to get the same. Like,
Exactly.
so like, what would you do? Would you do two separate ones, like a squared plus b squared? C
Right
squared?
off the bat, we know it's not a parallelogram.
Oh, okay.
Is that all we needed?
Because the slopes have to be the same. If the slopes aren't the same, we're done.
Okay.
Right? It's like saying if the distances aren't the same. In a parallelogram, the opposite sides have the same distance. They're equal. If they're not, then it's no longer a parallelogram.
And
You don't have to do anything else. What?
A and B.
So, how we solve this, do we know that it's
Yes, we do.
just because,
Because we found out what the slopes were,
yeah,
and we found out that the distances are the same.
Wait.
Go.
A squared plus b squared plus c squared. A and B can be interchanged.
Right. Those are called the legs.
the left. If
Legs.
we,
Go.
automatically, because the slopes were the same, don't you just know? Do you have to do the distance formula, or can you just know that they're the same?
That's what I drew this out here for. That's what I'm saying. Look, I'm going to try one more time.
Yeah, when you like drew out the line.
Yes, that's what I'm saying. I can extend.
This is
Shh, 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 shh.
Whoa.
All right, so what I'm trying to say is what I did was I extended this right here to be parallel.
But then doesn't the
But if I draw,
the slope doesn't change. It's just like because it's bigger, but then you can divide it, so it's the same thing.
it's not, it's no longer a parallelogram, because if I erase this and I draw now from here to here, it's a trapezoid.
Wait,
All
what
right,
if they're not
one
be a
side
right
is parallel and one side
What
is
is it,
not parallel.
Would they be a right angle?
No.
An upside down triangle?
So do you have to find the sides, or is it just those two, like,
I don't know what you're asking.
So,
Look, hey, again, all right, you guys, William, I'm not sure what you're doing back there. Listen, you're probably not doing anything because you never do anything. Trey, I'm not sure what's going on. I just know there's a distraction. William, stop acting like you're jumping on your cross here and being crucified because I called your name. That's not it at all. I'm trying to say you guys are distracting me, Trey, and I'm tired of it. That's all I'm trying to say. People are actually interested. I don't care if you're not. Now what?
so
No, hold on. Here, I know what I was going to say. Listen, if you want to know the rules, they're trying to give them to you right here. They're trying to give them to you right here. They're saying if the slopes are equal, then it's a parallelogram.
yeah.
If the distances are equal, it's a parallelogram. If one pair of sides are equal and they have the same slope, it's a parallelogram.
Like, can't you just do it by slope or distance, or do you both?
No, it just tells you.
We just said if you want to prove one side is parallel, that is not enough to prove that the triangle or that the quadrilateral is a parallelogram.
So why did we
If you want it to be a parallelogram, you have to show that either both pairs of opposite sides are parallel, which is number one, or you can do both pairs of opposite sides are equal,
that's
or you could do one side parallel and the same side congruent. Then it's automatically a what? Parallelogram. That's what they're trying to tell you. Now, over here, I want to get to question number 6. To me, is the easiest one. All right, number 6 is the easiest. All right, because all you have to do is find the midpoint, which is simply the average of the x's and the average of the y's. If those midpoints are the same, then it's automatically a parallelogram. Because in that particular case, the diagonals would be bisected. I should say that the diagonals bisect each other. All right? If you construct a quadrilateral and the diagonals bisect each other, then it's automatically a parallelogram. That's what they're trying to say. So again, for question number 6, I'm looking at this saying they don't always go in the right order. So in my opinion, you should kind of visualize it. And remember, Ryan, I'm not doing it exactly. I'm just roughing it out. So if I'm placing 3, 3, I know 3, 3 is roughly up there. That's F. Then 1, 2. 1, 2 would be somewhere over here. That would be G. Then H. Negative 3, 1. Now, negative 3, 1 would be over here. That would be like H. And then negative 1, 4 would be up here somewhere, which would be I. Does everybody see that?
Yes.
So now what we're doing is we're looking at FH. FH would be the diagonal. So what's the midpoint of FH? The midpoint of FH would be 0, 2. Anybody else get that? 0, 2 for FH. Now I'm doing IG. The midpoint of that would be?
0, 3.
I got 0, 3.
So it's not.
So it's not a parallelogram.
That's so easy.
It's so much easier. And again, that's how I would do them all, honestly.
Yeah.
Right? There's just no point in doing the other stuff. All right? But the point is that it's just a really good review of slopes and distance formula. That's all. Because personally, I would never do it any other way. Girls, it's the same for you guys. as the boys. Right? The same. You're distracting.
What two X's did you use?
All right, so I drew it out and I rough sketched it so I could see that FH would be considered the diagonal.
Oh, so you just did it. Okay.
Right? And then I knew that IG would have to be the diagonal.
Yep. That's good.
Right? So then I just looked at those letters and did the average of the X's and did the average of the Y's. All right? What time do we got here?
Like 1 minute.
1 minute. Okay, so listen, unfortunately, which is kind of good because we actually have a little bit of time. All right? Tomorrow, listen, does everybody understand now? Look, I try to make it perfectly clear on questions 1, 2, 3, 4, 5, and 6. You know, my feeling is I'm not making you do something if it's easier to do it a different way. So you should say that question 6 is the way we should do them all. That's the way I hope you're thinking about it. But more importantly, when you take standardized tests, and some of you are going to be doing that soon, when you take an entrance exam, they're going to ask you about the midpoint, and they're going to ask you about the distance formula. That's why I'm taking my time and going through this. You're going to see it on every standardized test. If you are trying to get into a private school, you're going to see this. And this would be for the advanced kids. All right? And that's your goal, is to prove you're advanced. And some of you aren't proving that to me, just by your attitude in class. All right? No homework, except make sure you understood what I said
Are we
today.
going to get our review sheet tomorrow? Or is it-
No, there's no. So the one that's on there right now was for today, but we didn't get to it. So that's what we're going to do tomorrow. Yes. Have a good day.